Hi everyone, this is Dr. Nally. So in this video I want to talk about how to do stoichiometric calculations when you're dealing with precipitation reactions. So just like any other reaction you learned in the previous topic, we can do stoichiometric calculations with reactions that form solids. So let me work through this example of a question that's highlighted in blue on how to do stoichiometry with a precipitation reaction. It says here, consider mixing 50 milliliter of 0.7 molar aluminum sulfate with 50 milliliter of 0.7 molar lead-2 nitrate. So there are a few questions we can ask in this, given that problem, but the one that I want to ask is, what is the mass of precipitate that's formed? So going back to the problem right here, since we were asked what is the mass of precipitate, we know that one of the products must form a precipitator, if not both of them. So what we need to do is first, just like any stoichiometry problem, you're going to start by writing a balance equation for this reaction. So obviously you have to work out a little bit from nomenclature what the formula is for each of these compounds, and then predict the products from the double displacement reaction, and then lastly assign a state of matter for each of the products. So let me show you the completed equation right here. Okay, so aluminum sulfate is Al2SO43, lead-2 nitrate is PbNO32, and then since it's double displacement, as we did in previous video, we would take aluminum here and pair it up with the nitrate, and we'll take the lead and pair it up with the sulfate, and we form these two compounds right here. Again, with the correct charges and the correct number of ions on for each compound. Then lastly, we would assign a state of matter for each of these compounds. In this case, you'll notice if you go through the solubility rules that nitrate salts are always soluble, so that's why this one is aqueous. And if you look at the sulfate salts, you find that all sulfates are soluble, with some exceptions, lead being one of the exceptions, so as a result, lead sulfate is solid. So when the question asks us for calculating the mass of the precipitate, it's really asking us to calculate the mass of the lead sulfate that's formed. Now, a lot of times it is okay to just go with this equation and start to do your stoichiometric calculation, meaning that you're going to calculate your limiting reactant and then calculate how much product you're going to form. But one of the most important things to remember about chemistry in aqueous solutions is that ionic compounds dissociate into ions, and some of those ions are not involved in the reaction. They are what we call our spectator ions. So a lot of times it's actually a lot more productive to isolate only those ions that are involved in the reaction. In other words, to write our net ionic equation instead of using the molecular equation that's shown here. So that's what I'm going to do with this problem. I'm going to simplify this equation to the net ionic equation. And here I'm showing all the steps. As you remember, the first thing you have to do is break all the aqueous species into their component ions and keep all the solids staying together as the ionic compounds. So this is what's shown on this equation, which is the complete ionic equation. And then afterwards, you remove all the ions that are the same on both reactants and products. In this case, the aluminum and the nitrate ions are present on both sides, so we remove those spectator ions. And in the end, we have 3 lead plus 3 sulfate going to 3 lead sulfate. We can simplify that equation to just sulfate plus lead equals lead sulfate solid. That's our net ionic equation. Now, just like any stoichiometry problem, as soon as we have our balance equation, even though this one looks a little different than all the other ones because it's in the net ionic form, we can go ahead and start to figure out what our product is. In order to figure out our product, as you remember, we would first have to figure out which of these two reactants is our limiting reactant. So let's go back to the original question. It says here that we have 50 milliliter 0.7 molar of the aluminum sulfate and the same quantity of the lead-2 nitrate. So what we need to do then, if we go back to our net ionic equation, we have to then figure out how much sulfate do we have from the aluminum sulfate and how much lead we have from the lead nitrate. So keep that in mind as we're calculating the limiting reactant here. To figure out how much lead we're going to have in our reactant, the first thing, of course, is we have to figure out how much lead nitrate we have, which is just multiplying the volume of the lead nitrate times the concentration, which is 0.7 molar, so 0.7 moles per liter. And then remember that the lead nitrate produces some amount of lead. So then what you have to do is use a mole ratio between lead and lead nitrate to convert the number of moles of lead nitrate to lead. In this case, it happens to be 1 to 1. So every 1 mole of the salt produces 1 mole of the lead. So then it's just 1 to 1. So then that is the number of mole of lead that we have in our reaction. You can do the same in this case with sulfate from aluminum sulfate. Now the difference here is, as you can see, the mole ratio is not 1 to 1 because in this salt we have 3 moles of sulfate for every 1 mole of aluminum sulfate. So you have a 3 to 1 ratio, so that ends up being the number of moles of sulfate ion. Now remember that that's not the end of it. First you have to calculate this, but then afterwards you have to figure out the limiting reactant. To figure out the limiting reactant, we have to divide the number of moles by the stoichiometric coefficient as we did in the previous chapter. So in this case, we divide this by the actual coefficient of the net ionic equation, which is 1 mole of Pb, so we get that number. And then for this one, we divide it again by 1, which is also the coefficient in the net ionic equation, so we get 0.105. And that tells us that lead is a smaller number, so that's the limiting reactant. Now once we figure out the limiting reactant, it's really fairly straightforward to figure out the mass of the precipitate or the product that's formed. In this case, we would use the limiting reactant, remember, which is lead. Okay, so we're going to start again from lead nitrate, convert it to the number of moles of lead. Once you figure out the lead, you can then relate it to the number of moles of lead sulfate through the mole-to-mole ratio between lead sulfate and lead, which is given by your net ionic equation, and that ratio is 1 to 1. And then afterwards, to convert it to mass, we can just multiply by the molar mass of lead sulfate. So in the end, our answer would be 10.6 grams of lead sulfate or precipitate is formed in the reaction.